just like a two-part question.
Let me see. I could pull it up here, or let's see. Pull it up. Well, that sucker's coming up. By the way, I did have a book. I let somebody borrow it, and then they took off and never came back. Yay, Jeff, trusting fool. But so maybe I'll order another one with all that teacher money I make.
I'll just donate it. I'll give you mine. Hopefully I'll never do it ever again.
That cool 35, well, I would say like 50,000 a year.
Yeah, something.
I would estimate.
So while that's warming up, anybody have something else you want to talk about or ask? If not, it's going to be a really short day. I do have a sheet, if we do want to transition to this later in the class, of just a bunch of word problem examples, just to kind of focus on that. Okay, we can do that in a bit. Here we go. How you guys doing? Oh, here. Did you guys get a chance to try out that practice test look? Well, I'm thinking about it. Number 4. Some of you guys might know how to do that, but officially we haven't covered problem number 4 in the practice test yet. So that's going to be the next test. I think this is section 4.5. This one goes up to 4.4. Past Jeff being overzealous. Ah. So where were we at, Spencer?
It was section 4.3, number 205. 3.
That's all right, I got it right here. Number 205?
Yeah.
There we go. Road trip. You guys can't see it. Gotta be, squeeze in there. All right, so Damien, is driving from Chicago to Denver, a distance of 1,000 miles. The x-axis on the graph shows the time in hours. This is one, right? Before I, okay. Right, this is the problem?
Yep, that's
Okay, thank God. Because I'll do like a whole thing and the guy's like, that's not the one. All right, you guys have had a chance to look at it. The y-axis represents the distance he has left to drive. All right, so the x-axis is hours since he left Chicago. The y-axis is distance he has left to drive. So what is going on here? What does this mean? This point, what does it mean physically?
1,000 miles.
He still has 1,000 miles because has he left yet?
No.
No, so he hasn't left yet, so he still has the full distance to go. Because that's fundamentally what this question is asking. It's asking, find the X and Y intercepts. Well, they gave it to you, so you're welcome. Right, they already gave them to you. You can see them. And then explain what they mean for Damien. Right? So then the other one you can figure out what that is. Where is he at this point? He's home.
Yeah.
How do you know? Because how far away from home is he?
0 miles.
Yeah. See, so
So then that's,
take it all the way to English when you explain this, right?
Yeah.
Okay, I like it.
Thank you.
You're welcome.
I really hope he dies when he gets there.
Oh, that's nice.
Because he's,
Yeah, Damien, screw you being in a word problem. Yes. Antichrist.
Can you do number 5A for me on the practice test?
Oh. Let's see. Yes. So practice test 5A. Oh, so that's one about the X and Y intercepts? Okay. So in general, okay, let's see who's gonna work today. Oh, look at you. 4x minus 9y equals 72. So in general, how do I find the x-intercept, for example?
Put in 0 for 1.
Yeah, so to find the blank intercept, you make the other variable 0, right? So to find the x-intercept, oh my god. Okay, so to find the x-intercept, you let what happen?
Y equals 0.
So what do you know so far about the answer? Y0. We just made Y0. And then you're going to figure out what the x component is. So if you do make Y0, what do I get? Oh shit. Yeah, you eventually get to 18. Dividing something by 4 is cutting it in half twice. Half the 72 is 36, half the 36 is 18. Or you just plug it back apart. So now, then you can fill in the rest of that point. So sort of, if you rank the point as you do each intercept, you're not going to make the mistake of getting the x piece and the y piece and throwing them together. X is 18 when y is 0. That's a point. Now you go find the y-intercept. Same way, just to find the y-intercept, you're going to make x0, solve that equation. Is that cool? Yeah? Okay, so eternally, how do you find the whatever intercept you make the other letters 0? For us, there's only 2 total letters. So you only have to ever make one letter 0 to find the other guy's intercept. Yeah, I like it. M-I-Q. Okay. What else you got? Let's try to do all the graphing questions now, and then the rest of the time we'll devote to word problems. How's that sound?
Yeah.
Sounds fun. Yeah. Can't get enough of that. You guys are all working on something. I love it. Maybe I'll just shut up. What's up?
Oh. Because
They have constitutions everywhere.
they're handing them out.
They're handing out constitutions. I love
the
it.
quad at
That's a useful thing to have. Yes.
student.
On homework number, page 379. I need help on 291.
What section is that?
Let me check. 3.5.
5. Which number again?
291.
What am I doing? What's this thing doing? I'm trying to be on.
Go back one and then scroll down.
It's, yeah, it's on 3.5.
Go back.
Now scroll down.
Scroll.
All right, that's not yet. All right, so 3, 5. Number which one?
291.
291. Oh gosh, this is the Elvira and Alethea problem. Okay. This one's gross because it's got a mixture of decimals and fractions, right?
Didn't we do this the other day?
We did. I don't think we finished it up, so, right? I kind of got it started. So let's finish this thing up this time. All right. You guys playing at home? There you go. So, what's one way you can set this up? The way that I sort of showed you. Yeah, that's always a step. But what kind of problem is this? Yeah, you can see as you can scan through it, it's got speeds and times and distances. All right, so now you got kind of like a form to plug stuff into. What am I going to label the rows?
Elvira, Alethea.
Yeah. Let's do E and A, just so you guys don't freak out with the names.
No, spell them.
There, done. They're in a study group. That means that a copy. Oh yeah, so this was, remember the one I gave you the little visual. They live 3.1 miles apart, and then they're going to travel and they're going to meet at a coffee house somewhere in the middle. So this is one distance and this is another distance. So we already know what the equation's going to be. If I do what, I get what? Add the two distances, I will get 3.1. So I know what the equation is going to be. I just have to create expressions for the distances. Okay, maybe. Do you, if you're doing this problem, do you have to know everything I just said? No. I'm trying to give you an example of how I look at these things. So let's see, what do we know? The 3.1 is going to come in later. That's going to come into the equation. What do I know for sure?
They're in a study group.
They're in a study group? I love it. So you can draw a little table at the coffee shop, and you can have, their study group. It took Elvira half an hour and Alethea 2/3 of an hour. So that's what I know for sure. So let's put in there. So what goes up here? I like it. So it took Elvira half an hour.
I did learn how.
30 minutes.
I did learn how.
You ready? Miles per. Every unit in the problem has to agree. So I don't want to put 30 up there because there ain't no 30 hours she traveled to do the study. Holy shit. She had to be there in time, so she wore a diaper and she just took off. Doing the astronaut kind of thing. You guys don't know that. So it took her half an hour. You must put either 1/2 or 0.5. In this case, it's fine. Let's put 1/2. And Alethea took 2/3. If you put 0.66, that's really bad. If you put 0.67, that's a little better, but still bad. Put freaking 2/3, that's the only way to have the actual exact right answer. You guys have a disconnect between what it means to estimate something. Rounding and decimal changes the number. So your answer is going to be off from what it's supposed to be. Just use a fraction. I know we don't want to, but too bad. Alethea's speed is 0.6 mile an hour slower than Elvira. So what am I gonna? Who's gonna get an X for their speed or whatever? Letter? E. Yeah. So Alethea's is 0.6 miles slower than Elvira. So if I call Elvira X, what's Alethea?
0.6x.
No, not. She's not 6/10 as fast.
It's X minus 0.6.
Yeah, she's 0.6 miles slower. So it's X minus 0.6. You got to be really careful about when to multiply and when to just subtract or add. Yeah. So pretty cool with what's happening so far. If you're not, speak up. Is there something up there that you're not sure where it came from? Okay. What can I do? So let's see. Blah blah blah. Oh, now we're set. And I want to remind you guys, this picture is a good picture to draw. It's kind of like a quick physical representation of what's going on. And then I can see better what the equation will be. Remember what I said earlier. If only I knew these two distances, they're supposed to add. Well, now what can I put here, for example? What's it telling me to do?
X.
Yeah. Multiply these two to get this one. That'll be 1/2 X. And what goes here? 2/3 of X minus 0.6. That's yummy. So now you can set the equation up. You can have opinions about what it looks like, but you can write it down, right? What's the equation going to be? Yeah, this distance plus that distance equals 3.1. Now you worry about the fractions. Now you have to deal with them. Until this point, I didn't really have to do much with them. I just had to carry them along. So don't let them trouble you here. Now you worry about them. But what can I do if I wanted to kill? Yeah. Right? You can multiply by 6 because that's going to kill those. Are you guys? All right. All right. Everybody's at least looking at me. And again, if you like this better, you can make everything become over 6. But really, I can just multiply each piece by, let me write this in a different color. You try to be a good teacher, see what that's like. And this will be multiplied by 6, this will be multiplied by 6. So what happens here?
Cancels.
So you become a 3. 3x. What happens here? 2 times 2 times, so let's just write this out. 2 times 2 is, that's amazing. And what's 6 times 3.1? 18.6. Kick ass. Not too bad. Alright. And I can distribute, blah, blah, blah. Yeah. Yes?
Where are you getting, isn't it 0.6 or?
It is 0.6. What is, I'm sorry. What did I lose? Are you talking about this one, or are you talking about?
Where you're doing multiplying everything by 6, is it just a solid 6, or is it multiplying everything by 0.6?
No, 6.
Where's the 6?
Because what's the LCD of the fractions that were there?
Oh,
6.
okay.
So that's the number that will kill them all. Right? Because 6 has a 2 in it, has a 3 in it, so it'll kill all the fractions. It'll have a piece that kills those things. Okay, maybe.
But why didn't you multiply x minus 0.6?
Kick ass. I was waiting for that question. All right, you ready? All right, let me say it like this, and then I'll show you a different way. What is 2 times 3 times 4?
24.
It's not 6 times 8, is it? What would you tell somebody who said, well, this is 6 times 8? What would you say to them? What did they do? What did they do? Can you guys see what they did?
They distributed.
Yeah, they kind of gave them both a 2. Well, what I would say is, it's only one frickin' 2. How the shit did it go to both of them? There's only one 6. The minute it dies here, there's only this much left to go through. All right, that's a little less satisfying. So what about this? So let me write down what we got. Isn't this 2/3 x minus 0.6, right? That's what that is. That's amazing. Let me write this in a little bit different way, but you guys, do you agree with me? I can write it like this. That's the same thing, right?
Mm-hmm.
So what happens when I multiply this thing by 6? Right? And then 2 times 2 is 4. But I'm not going to do 2 times this because it's exactly what I had up there earlier. 2 times 3 times 4 is not 6 times 8. So 2 times 2 times this, the 2 can't go to both. It is all multiplication. That's all it is. So 2 times 2 is 4, and then I, because what's the right way to do 2 times 3 times 4? 6, and then you multiply by 4. So 2 times 2 times this. Okay, that's 4, and then I can multiply that through. A little bit. So remember, multiplication distributes across addition, but there's no reason why it would distribute across multiplication. It's all one level. It's just going to attack itself, right? I know it's a little weird, but hopefully something in there made some sense. Yes.
For the top part where you're trying to get the into like solid numbers.
Here.
Yeah. Is you once you get the once you know you're supposed to divide the top numbers, or
Well, if I multiply each thing by 6, how do I multiply something by a fraction? I try to reduce, right?
Yeah.
That's all we're doing there.
Ah.
Now, let me show you a different way. If we do this sort of like more like what we did earlier this semester, what I would do is I try to make each bottom become 6. So I multiply in by 3, 3, multiply in by 2, 2, and then he's going to have to multiply by 6, right?
okay.
So now they'd all be over 6, so I can multiply everything by 6, and what would be left there? 3x. 4 times that, and 3.1 times 6.
Okay.
Yeah, so either way you do it, it works. Maybe. You guys all right? Some of you guys look resigned to your fate. I don't like that look. Stop that. This is just error. Okay. All right. So there's that one. Almost done. I mean, now distribute the 4, 3x plus 4x. 4 times 6 is 24, so 4 times 0.6 is 2.4. Yeah.
Oh.
Not a big deal at all, believe it or not. And the nice thing with 2.4, notice, is if, this is going to sound weird, but it fills this dude in nice. Right? 21. And then that's really nice shit that you didn't expect at all. Right? That goes in even. Holy crap, problem. That's nice. The problem's like, I know I was real bitch in the middle about all these decimals, and so let me be nice at the end. Right? For some reason, this problem is a female form. All right. Maybe. Did I answer everything about this question yet? It wants both women's walking speeds. What did I just figure out?
You figured out
Elvira's walking speed.
Yeah.
And then to get Alethia's walking speed,
You can
yeah,
plug it in.
yeah, just subtract 0.6 from 3, right? And you better put units, yeah. You don't want me to be all dorky. I am, but don't make me be more dorky. Light years per second. All right. Anything else from? I feel like we've transitioned over. Yes.
You do 305 in the same chapter.
Okay, this one's, so anytime they have like an everyday math section, there's a high probability that it's not going to require algebra. I'm not saying always. So John left his house in Irvine at 8:35 a.m. Good luck, John. Driving to a meeting in Los Angeles, yeah? You arrived at the night, that sounds right. All right, so we got a lot of information here. So let's see. What was his average speed on the drive from Irvine to Los Angeles? So how do you figure out speed? What do you do? Well, what's the formula again?
Distance, rate, time.
Solve for speed, solve for the rate. What do I do to solve for rate? Let's divide by time. Distance divided by time. In fact, you guys know this. Give me a speed that you could go on the road.
6 miles, 60 miles.
That's true. 4 miles an hour, 60 miles an hour, miles per hour. So how do I calculate speed? I take distance divided by time. It's in the units. The units are telling you what the equation is.
5 times
Or we can just do it and see what the equation is. So from Irvine to Los Angeles, how far did he go? 45 miles. So that goes on top. How long did it take him? In hours. Oh shit. Well, how long did it take him? So this is the part that gets interesting.
an hour and 15
An hour and 15 minutes. This is the part you guys have got to... Okay. An hour is a nice number of hours. I don't have to worry about this. The 15 minutes we've got to convert. It's a part of an hour. It's going to be a decimal part. It's not 0.15 because there ain't no 100 minutes. It's 15 minutes out of 60. So you just got to do that. So this will be 1 hour and 15 60ths hours. Yeah, so when you do this, it's a quarter of an hour. I could have just said that. I mean, if it's 15 minutes past 3, how do you say that? Quarter past 3. That's why it comes out to be 0.25. It's a quarter of an hour.
Yeah, because 60, if you divide it by 4, is
15.
Yeah.
Sweet. Let me stop for a second. So there's no algebra involved on the first few problems looking through this real quick. That really the hardest part is just converting to hours. You have no minutes floating around. How fast you go? About 20 miles per minute. What are you? That's pretty fast. So let's see. Do we got everything we need? Yes. So now I just got to do this, and thankfully you can use your calculator or whatever you got to use. 5, 4, 9, 36. Yes, it is. Sorry. I teach this shit. I better know how to do this.
Kilometers.
Kilometers?
Yeah, kilometers, I'm sorry.
I don't want to do it.
But if I go to another country, I won't go home.
Well, go there and then call me. Alright, so. And then part B is the same thing, you just have to do exactly what we just did, just for the other way. You know it's 45 miles, and now you can see how long it took them. Maybe? Is that right? And then let's see what C is. Total time he spent okay, give me a break. Right? Sometimes the questions are like, it can't be what it sounds like, because that would be too easy, but just freaking add the times, right? This happens every now and again in this homework, and I like that. It tries to make you remember, don't get stuck in this mode that everything has to be like in a box or some. No, some of the questions they ask are just add these two things. But part of your brain goes, can't do that. John drove a total of 90 miles round trip. Yes, he did. We know that shit. Find his overall average speed. So, the average speed for anything I do is going to be the total distance I went divided by the total time it took. I know the total distance is 90. Part C says to find the total time, then you just have to divide those two. Not a problem. Is it a problem?
Yeah, say it again.
So the average speed for anything is the total distance I went, 90, divided by the total time it took me. That's part C.
2.5.
Whatever it was, yeah, when you added it 2 times. Yeah. It won't be 2.5 because it took them longer to go home, right? It took them 1 hour and 48 minutes.
So it's the total distance times,
Divided.
divide, okay.
Divided by the time.
I heard that.
So you do this for part D, you do the same thing we did for part A. You just use the total distance and the total time. That's all you do. Okay. Maybe. Anything else from the practice test or homework or?
Can we do number 4 on practice test? Okay, let me see, this is in where? 3.6.
Number which one? No, guys. I had a question right before that. We'll do Valley's question next, but 320? Natalie is considering 2 job offers. The first would pay her $83,000 a year. Yeah. The second, now, if you read this too quickly, you might miss out on an opportunity. The second would pay her $66,500 plus 15% of her sales. So depending on how much she wants to really work, it sounds terrible. What would her total sales need to be for her salary on the second offer to be higher than the first? So it's the first one is set, $83,000 a year. There's nothing to do with that shit, right? How do I write an expression that represents the second? What is it that I don't know? She doesn't know what?
The total sales.
What total sales she's going to have. So we're going to call that.
I don't know. I
No, you're
chose.
fine. You can call it whatever you want to. I was going to take whatever I heard first.
I know.
And I heard X. You can call it M, you can call it happy face, you can call it whatever. Okay. There you go, perfect. I want that to happen. Where'd it go? There it is. So if we call that X, how much money total would she make in a year then? How much money does she make no matter what? $66,500 plus
15%.
15%. Now watch this. Some people did something related to this in the homework when it said 15% of something. How much extra money, if I just stop right there, is she making? 15 cents. Thank you so much. She's like, wow. This and 15 cents? Dude. So what am I missing? Because it's 15% of sales. Of we know is multiply. Now, what do you want to be true? It said how many sales to make the second offer, that's this one,
Higher.
higher. So what goes here? No way. Than the first offer. 83,000. So how do I make this offer greater than that offer? I can see. And this kind of problem, I love this kind of problem because, for example, I used to live in North Park, and there was like a North Park fitness center I used to go to. And they let you pay a certain amount down plus a certain amount per month. So you can kind of pick how much you want to put down, and then your per month went down a bit. You guys with me? So it's like, how many months would I have to know ahead of time that I'm going to work out here to know which one would be the best thing to come out? Do you guys understand what I'm saying? So that's exactly like this. Okay, maybe. Or, and then you just solve this like you do anything. It is an inequality, but there's no negatives. That's the one thing I have to be careful about with inequalities, right? Yes?
So you just solve it like a regular equation?
Of course. So the first part of the word problem is setting it up. Once the equation is set up, I don't give a shit where it came from. You solve it. It has nothing to do with where it came from as far as how to solve it. We know how to solve equations. Is what I'm going to find out soon. Right? I mean, this is not bad, right? What would you do?
Subtract 66.5.
Now I sort of want to know this. So 0.15x is greater than,
Good math teacher.
yes, see that should happen? I was sort of waiting to see if anybody would, but no. Go, math boy, go. And then divide by 0.15.
Sounds more like a sidekick.
Damn, that's a lot. Let's see. Oh, somebody already said it? All right, thank you for saving for myself. So if she knew she was going to make at least that much in sales, she would do the second option.
It sounds like a lot of work.
I mean, if she's
Well, depending on what she's selling and what the demand is like, right? I mean, if she's selling
Teslas, that's like
if she's
11
selling
Teslas.
parkas in San Diego, I probably don't know. But you know, if she's in Teslas.
Teslas, that's like
Didn't the
11
Tesla
Teslas.
car just have a horrific accident again recently? Anyway, let's not talk. All right. So that whole section 3.6 was about inequality. So if you're doing section 3.6 and you don't have any inequalities in your work, you are wrong. You need to stop, back up, pay attention to words like higher, less than, whatever. Okay. Okay. Was there somebody else had a question? Holly, you had a question?
Yeah.
All right.
Doesn't matter.
Okay. Anybody else?
I forgot.
You forgot?
I
Okay.
forgot.
Back to the Elvira question.
Yes.
So how did you find the walking speed?
Where are we at?
Um,
How did I find the?
their walking speed?
Oh,
Because you had to plug it back in, but I don't know how to set up that equation.
the beautiful thing is, if you're cool with what we did up here, right? Like you're like, sure. Are you cool with what we did up here?
Yeah.
Okay. And if it's a no, it's okay. Because I bet you there's other people that say no. That led to the equation. We had to kill some fractions, but we made it, right? We feel sort of bad, but not really about killing some stuff. They're just fractions. We got to 3. The reason that this is such a great step, defining variables, and a lot of people skip this shit. If you define it, you know exactly what the shit your answer means. 3 miles an hour for who? Elvira. How do I figure out Alethea?
Plug in the X.
3 minus 0.6, because x is 3.
So, like, where did you plug the 3 back in then?
Well, what is 3? X.
Yes.
So x is 3. That's Elvira's speed. So what's Alethea's speed? 3 minus 0.6.
Oh, okay.
Because I know x is 3 now.
Okay, because I was like setting up an entire equation. Like,
Dude, no, you already did that. So once we know the value, we can go back to the expressions we wrote.
You're only focusing on the rate, like everything.
Yes,
else.
exactly. If they would have said how far did they go, I could have put the 3 here
Okay.
and there.
Okay, I see.
But they didn't, so I don't have to worry about that. I can just focus on this piece.
Okay.
But you're right, anywhere there's a Whatever they ask me for, I see where the variable is, and I use it to figure out that thing.
Okay, so Alethea speed would be just 3 minus 0.6.
Beautiful.
Okay.
Miles an hour. Yeah, I like it. Okay. Maybe. If you are skipping the step where you say stuff like Frank, Bill, Bob, and then doing the variable stuff, you are being so mean to yourself. It's not me. I am mean to you, but not that way. You can be nice to yourself and tell yourself exactly what the hell's going on in this problem. A lot of you guys are skipping that step in the homework, on the quiz. Don't. That's one of the most important steps. Okay. I do have of course we had to throw out 7C, but let me do this. Look at 7C. On the key, I actually gave us more information, and then I worked it out. So 7C, if I take that part that says this, Fred travels 2 miles an hour faster. You with me? Cross it out. Underneath it say, Fred, oh shit, now I gotta remember which one I made which. Fred travels 15 miles an hour. And what was it? Jim travels 20 miles an hour. Now try to do the problem. So just change that sentence. Fred travels 2 miles an hour faster than Jim. Screw that sentence. Make it this sentence. These two sentences, sorry. And then try to do that problem.
I was gonna write dim. Great.
Huh?
I was gonna write dim instead of June.
Oh, you might be dim. I don't know. Everybody has a practice test, right? So if I'm you, I'm going to do like I always try to tell you. Look for what you know for damn sure. Doesn't need any variables. What do I know for damn sure? Yeah, Fred went 15.
20.
Jim's running 20. I have no kind of idea what kind of vehicles they're on. It's not just them running. They're not part of the Super Soldier program. And we already talked about this next bit last time.
Isn't time X?
Time is X for both. It's a normal race. They're going to both start, and then I kind of snapshot stop them. Which means what can I put here now? Yeah, because distance is rate times time. Bam! This, of course, is going to be 20x. Now, here's the trick. Oh, yeah, it's not a third check. It says how long until they are 10 miles apart. So if they start racing and one of them's going faster, that's going to happen, right? And I want this to be 10. What's that translate into as an equation? Think about it. I want it to be, so here's who's faster. I forgot. Jim's faster. So Jim runs and Fred's like, damn. And I want this, I want that to be 10. So Jim's distance minus Fred's distance, right? The other one, notice the problems where we added them was Either they started here and they met somewhere in the middle, so together they went a total distance, or they started in the middle and went out, so together they went a total distance. Here, they're going the same direction. And then I want the distance between them. That's subtraction. How far apart? How far apart are the numbers 15 and 9? You subtract. So that apart kind of means subtraction. So then to make the equation, I want Jim's distance minus Fred's distance, and I want that to be 10. And that's not a bad problem now that I gave us enough information. Thanks, Jeff. So what do you?
5x.
Yeah, it takes 2 hours. Thankfully, that's all I need. That's the only variable that's up there, right? I didn't ask for how far they went. Just asked for how long until they have a couple hours. You see why that makes sense? If they're going 15 and 20, in 1 hour, how far will Fred have traveled?
15 miles.
15 miles.
20.
20 miles. They're how far apart?
5.
5 miles. So another hour, they'll be another 5 miles apart. They'll be 10 miles apart in 2 hours. Of course they will. Okay, man. All right. So that's the one I want to do for sure because I changed it up a little bit so we could do it. We did the other ones last time, right? Yes.
Yeah, number 4. Where did you do that one?
4, I said that's going to be in the next test. So that's just one that survived
That's fine.
my editing. Yeah. We haven't, I think that's the next section after 4.4 is where we connect, we make the mx plus b, but we haven't actually looked at that yet officially. Some of you guys might remember mx plus b. Huh? Number 4. That kind of problem will not be on this next test. It'll be on the test after this one. I think it's in section 4.5. I just didn't kill it when I should have killed it. All right, so let's see if you guys want to do this. I'm not hearing any more graphing questions. And I've got that sheet, like I said, of a lot of different word problem examples. Let me give you that. What do you need in your life? More problems. Here you go. What's up? 3 minutes? Well, that sucks. Well, I guess I can still give this to you, but if you get time and you want to try some of these out, I can tell you if you're right or not. I didn't bring the answer. But in the probably 2 minutes I have left, yep. Okay, let's look at one of these. Like, I love the first problem. The first problem is related to problems we looked at before, but we never really looked at one quite like that one. So look at the first problem real quick. The last whatever. Yeah, okay. What teacher let you out on time? I let you out early a few times, so deal with it. The part that you guys skip more than I thought you would. I thought I made this really, really clear. It's not a requirement, but shit, if you don't do this, you're going to make mistakes, almost for sure. What's the first thing I'm looking for when I read through this? Do I care about the numbers or?
No.
What's dependent on what? Right?
Not yet. The very first thing is just
The subject.
the players.
Yeah.
11. So what are those? Yeah, second piece, first piece, third piece. So it's really kind of important to call it the exact things that the problem does. So you can always relate the problem to the math. And this is their length, right? Now you worry about, like you said, Spencer, what's dependent on the other thing. I need to know first. Yeah, kind of. I got to know the first one first. Say again? I don't know yet. We're going to get there. Yeah. So if I call the first piece X, what's the second piece going to be? It's twice as long. 2X. What about the third piece?
Plus 3.
Yeah, see, this is a beautiful example of what's multiplication and what's addition. This is 3 longer, so it should be X plus 3, not 3 times. This is the one semester I had this as a piece of wood at one point, and I had a dude in the back of the, I think it's the second class I ever taught. He was like, Mr. Waller, you know, when you saw wood, you lose about 1/8 of an inch of the wood off in the teeth. I'm like, you can set your word problem however you want to. We're using lasers to cut this shit. So, anyway, there's a bigger discussion, but we have like -1 minute or so. What are these things supposed to do now? So again, hopefully we've done enough of these. You can see the flow. What are the players? I don't give a shit about the math. What's going to have to be X, and then build the other two. And now what do they all do together? Yeah, when I do what? Adam. So a lot of you guys on your, what was it, 59? Yeah. On your quiz, I said things like, you went halfway on that rectangle problem. A lot of you guys went halfway. Or a lot of you guys just put one side and put all the wood on that one side. I'm like, okay, put my pet in there and it just wanders away. Or it's got to be really dumb. I face it and Vince is like, oh, I can't go anywhere. You want to freaking get all the sides. That's why you should probably draw a picture, a geometric thing, and you want to draw a picture. This one you just solve like you always would. 14, what is it? Meters, I love it. 14 meters, 28 meters, 17 meters. And then how do you check yourself? Add them up. And it makes 59, thank God. So sorry that I forgot today was like the short ass day. It's either we have a long day of review and then a short day for the test, or we have a short day of review and a long day for the test. You tell me which way you want. All right. So I'm going to go back to my office and upload